After working with all those properties in part 1 of section 1.2, we're now ready to move on to something that's going to look much more complicated, but it turns out most of the work is actually done for you. All you're doing is just providing the brain power. So here's the I can statement for part 2. It's I can justify algebraic steps. So let's write the word steps in here when solving equations. So we already know how to solve equations really well. We're just going to look at justifying the steps that we take when we're doing that. So the warm-up question, it says, what does it mean to justify something? So if you stop and think about that for a second, if somebody says, hey, well, can you justify that? What it means is give reasons. So let's write down give reasons. So when you justify something, what you're doing is you're giving reasons for whatever you're doing or whatever you want or something like that. So I want to run through this paragraph right here because I think it's really important. One of the most important things you can learn from math is the ability to think logically and step by step. There are those words there again, steps. There are many times when this ability will come in very handy. There are lots of things that require us to follow or even give directions one step at a time. Think about if we get a piece of furniture from IKEA or a toy or there's a game or something like that. We need to follow the directions, and there are actually people that have gotten really good at what's called technical writing. They write things step by step so that other people can understand them. And you're going to have a much better chance of people understanding you if you can construct step-by-step reasons. You won't win very many arguments with your parents or convince your boss that you deserve a raise unless you can justify yourself. And again, when you justify yourself, that means you're going to give reasons for your actions or prove yourself. You're going to give your boss a reason that you need a raise. You're going to give your parents a reason why they ought to let you do whatever it is that you want to do. So let's take a look at this first example right here. This is example number 2 in part 2. You'll notice that we've got a bunch of blanks here. This looks like a total mess right here. Looks absolutely awful, but basically what we're doing is we're just showing the steps to solve this equation right here. Now, yes, this does have some fractions in it and stuff like that, so that might be a bit of a mess, but all we're supposed to do here is just justify every single step in here, even the tiny steps. And you'll notice that it says that the steps here and the answer are correct. So we don't have to worry about, what to do next or whether the answer is going to be right when we get done with it. All we're supposed to do is just provide the reasons or the justification for each one of those steps. So here's the original equation, and then here's the first line that we need to justify. And one of the best ways to do this is to think, what changed from one line to the next line? So this is the original equation, so let's call this line 1, and now we're on line number 2. Well, what happened from here to here? Now, I will warn you, we're going to get ridiculously detailed here. I mean, we're not going to skip any steps. We're going to show all the work on both sides. And again, the cool thing is the work is already shown for us. All we need to do is figure out, well, what's the algebraic reason for what was done here? Now, in order to help with that, it might be a good idea to have this page right here. So this is page 1 of the notes. So all of the properties are indicated right here along with an example. What we're looking for is we're going to be giving these names right here. And again, on some of the long ones, we might shorten that up a little bit. We're not going to use every single one of them on every single problem, but we want to be able to recognize, hey, what happened from one line to the next? So I'm going to call this page up if we need it occasionally, but let's just take a look. So on this side, it used to say 7/4 n plus 5. Now it's got that in parentheses and we're multiplying it by 4. And on this side, it used to be 1/4 n minus 9. And now it's got that in parentheses and we're multiplying by 4. So basically, we're multiplying both sides of this equation by 4. We're going to clear that fraction there, that denominator of 4. So we're multiplying both sides of the equation by 4. Well, that's part of the golden rule of algebra. That's called the multiplication property of equality. So we're going to simplify this and write it a little bit shorter. Whoops. We're going to write MULT period. I told you if we abbreviate, we want to put a period. So we're going to write multiplication property. Now on this one, I'm going to write of equality. And then a lot of the rest of the time, I'm just going to write a little equal sign there for equality. So that's the multiplication property of equality, the fact that we can multiply both sides by the same thing and it still makes another true equation. Now, what happened from this line to the next line? Again, that's the best way to kind of think of this. What changed from this line to this line right here? Well, you'll notice what happened is we've got a 4 times the 7/4 n and a 4 times the 5. So basically what they did is this on both sides. So we're just going to write down, hey, what they did is they did the distributive property. Distributive. So we'll just write distributive there and we're all set to go. So this is literally what the work is on the assignment, is just going through and justifying each one of the steps. Now, what happened from here to here? So what they did is they changed this 4 times 7/4 n just to a 1n. Well, they canceled off the 4s. So that is the, let's see, what's that called again? That's the multiplicative inverse property. They did a little bit of simplifying here. They just did the arithmetic. So 4 times 5 is 20. They canceled here, same thing there, multiplicative inverse property, and then they just simplified 4 times 9 to negative 36. So what we're going to say here is we're going to say multiplicative inverse, and I'm just going to do multiplicative inverse. And for this other stuff, you could either write that they just did some arithmetic. I'm just going to write that they simplified. Okay, so multiplicative inverse on each one of these, and then they just simplified when they had the numbers there. Now, the only thing that changed from here to here, and I will grant you this is a little bit nitpicky, a little bit on the silly side. They did 1 times 7n is 7n. The 20 stayed the same. 1 times n is n, and the negative 36 stayed the same. So the only thing that they did is they took advantage of the fact that if you multiply by a 1, it doesn't change the number at all. And you'll remember that's called the multiplicative identity. So the only thing that they applied right here is the multiplicative. So we're just going to do mult, and identity, I'm just going to use ident. Okay? So again, if you abbreviate something, please make sure you write enough of the word that people can tell what you're talking about, and then put a period so they know that you are abbreviating there. Next thing, what's going on here is they're just subtracting n, so that's the subtraction property of equality. So subbed prop and equal sign. Okay, so the subtraction property of equality. Let's see, and then what they did here is we'll take a look here. Those are additive inverses, and they just simplified. So I'm just going to write additive inverse and simplify on the other side. Okay, so just a little bit of simplification. They collected like terms basically there, 7n minus 1n. Next one, let's see, we went from here to here. So this side stayed the same, so we don't have anything to worry about over here, but we do have to look at this. This is 0 minus 36. Remember, when you combine something with a 0, you get the same thing. So this is the additive identity. So I'm going to write add and identity, so ident there. They're subtracting from both sides again, so we're going to write the subtraction property of equality. Make that look just a little bit better. And then let's see, they got a 0 here, so what they're showing is that these are additive identities, so we ended up with additive inverses, so we ended up with a 0, and then they're just simplifying here. So additive inverse and simplify. So you'll notice that this is the same step as we had up above here. That will happen quite a bit. And we're just kind of following this down here. What happened from here to here? Well, we've got a negative 56 and we've got a 6n plus 0 that turned into a 6n. So let's see, that is, well, we added 0, it stayed the same. So that is the additive identity. Same thing that happened on this one right here. And then they are dividing both sides, so that's the division property of equality. They just divided, and then what happened here, notice we went from 6n over 6 to 1n, so you might be able to think of what happened there. And notice that they didn't touch this at all. That's fine to leave it that way for right now. All they did here is they just used, those are multiplicative inverses. They canceled each other out, they turned into a 1. Whenever you find yourself saying, oh, those just cancel each other, you're going to be using an inverse of some sort. So this is going to be the multiplicative inverse. And then we went from a 1n to just an n, so they're not writing it anymore. So 1 times n is just the same thing. It maintained its identity. So this is the multiplicative identity. Okay, and then this side stayed the same, and then the only thing that happened here is we just simplified. So we're just going to write simplify. And to be a little more specific, we can say simplify the fraction. You could say they canceled a factor of 2 or something like that, but just say simplify or simplify the fraction. That'd be totally okay. All right, so I realize this looks like a lot of work, and it's really not a lot of work. What it is it's a lot of thinking. So what we're doing is we're looking at each one of these lines and we're figuring out, okay, how did they go from here to here? We are justifying each one of these steps. So let me let me just shrink this down just a tad so we can see the whole thing all at once. If you started off and your boss gave you this problem and you immediately said, oh, well, the answer is negative 28/3, they might say, well, how do you know that? Or why? Or can you tell me how you got that? This is step by step. In fact, this is like ridiculous amount of detail to walk them through from step to step to step to step. We're breaking it down in little tiny step-by-step instructions and reasons and justifications for being able to do that. So that's kind of the idea. That's the brain power that we're developing here. So what I'm going to do is I'm going to come down here and we're going to take a look at this one. We've got just a couple more here and then we'll turn you loose on the assignment. It says the steps and answers below are correct. Justify every step. So we started off with 2 to the x equals 32, and now it says 2 to the x equals 2 to the 5th. Well, stop and think about this. I think we did one like this in the last practice session. The only thing that changed was we replaced the 32 with a 2 to the 5th. Well, what we did there is we plugged in 2 to the 5th for 32 because they're equal to each other. What we did is we used the substitution property. So substitution property. Now, if you wanted to, make sure nobody mistakes that with subtraction. That's why you want to put the TR on subtraction. So substitution property there, substitution property. And then this one right here, well, gosh, I mean, we're done here. The answer is just x equals 5. Well, where did the 2's go? Where did those bases go? Well, this was the equality property of exponentials. So we're going to put equal prop of exponentials, and I'm just going to write expos, so for exponentials. Now, on this last example here, it says, what would be the first step to solve and justify this equation? So if we were to look right here, now, again, this is where we want to get into the real detail and thinking about, okay, if somebody said, well, why can you do that? You want to be able to justify it. You want to give them a reason for it. So the deal here is most people would look at this and go, oh, well, there's nothing to do over here. So that side's simplified, but we do have to simplify this side over here. And we'd say, well, you can't add these together because they're not like terms, but you can do the 3 and the 7. So what most people would do is they would just write 2x plus 10 equals 4x plus 2. And they'd say, well, that's what I would do first. But technically, here's what we ought to do. Instead of grouping the 2 of those together, what we ought to do is we ought to group the 3 and the 7 together. So what we're using is we're using the associative property of addition in order to put those together and just show that we put those together. So this is the associative property of addition. And remember, there was an associative property of multiplication as well. Got to be careful with subtraction and division. They do not have as many properties as addition and multiplication. All right, do the self-assessment there, and then good luck with the assignment.